I will be talking about tuned mass dampers, also known as harmonic absorbers. These are huge structures that are mounted in many places, but why? I'll tell you. Do you know what a skyscraper is? They're tall buildings, and tall buildings sway, but they should not. Today I will be talking about tuned mass dampers, or TMDs, which are a creative solution to this problem. Since skyscrapers are so tall, we tend to encounter many problems with structural support when dealing with them. This has been an engineering issue for decades. Ideas to help with structural support exist, but many tend not to be either cost-effective or practical. The idea of a TMD is similar to a block on a spring or a pendulum. Both examples contain a mass moving back and forth due to having some kinetic energy. This can be created in several different ways, but for buildings, we assume that the kinetic energy is built up from either wind or earthquakes. And TMDs are a way to discourage the swaying in a building. A phenomenon happens when two things are in motion are somehow connected. This is usually by a spring. The two objects tend to share energy with each other. The switching of energy between each of the masses causes this energy to slowly dissipate. We know this happens due to energy being lost when being switched due to either air resistance, friction, and some of the energy being transferred into heat. Frequency is used to describe when something happens over and over again. It is said to have a higher frequency when it happens more often in a set time, and this usually comes with more energy in the system. This is just like when you tune an instrument. You can manipulate the thing you are tuning to have a desired frequency. The main idea in this TMD is to use a smaller object to dampen the frequency of a building that oscillates. TMDs are tuned to have a frequency while they sway. They can have a bigger or smaller effect on the building, so engineers have to take into consideration everything that is in the system. This includes mass of the building, height of the building, mass of the damper, springs constant, the position of the damper, and so forth. Hence the name tuned mass dampers. After being tuned to cause the fastest possible loss of energy, the TMD is ready to be set up. Some pictures in real-life TMDs show how they can be used in a wide variety of applications. In addition to buildings, they can be used to stabilize other structures, including bridges, boats, even power lines. Thank you for listening to my Curiosity Project.